Today we are going to learn the electricity consumption forecasting using fuzzy inference system FIS from Matlab. So the outline for today lesson including introduction, fuzzy inference system FIS, material and methods including the data structure, methodology, performance, result and discussion and conclusions. Okay, as we know that time series is a collection of equally spaced temporal data. Okay, for example, like the graph shown here is monthly number of airline passenger from years 1949 to 1961, which is in the increasing trend. And we are going to use a fuzzy inference system from Matlab where we have the input will go into the fuzzifier to fuzzify the input into fuzzy set going the FIS the fuzzy inference system, and then the fuzzy set will be we'll have the fuzzy rules there. We have the fuzzy rules. After that the fuzzy rules and the fuzzy set will be defuzzified to give the predicted output. For example, this is a trapezoidal membership functions. This input variable is a temperature. You may have the, let's say, very low temperature. You may fuzzify the temperature variables as very low, low, medium, high, very high temperature. 5 fuzzy membership functions. And then our material and methods. The inputs for our data is actually monthly electricity consumption. I mean from UTHMs. The input is a same month of UTHM electricity consumption from year 2009 to 2020. For example, with the input of January electricity consumption from 2009 to 2020, the January 2021 electricity consumption will be forecasted. The process is repeated for February, March till December. So this is from the fuzzy logic designer from Matlab. You have this is our January input, and we choose the Sugano where the output is a constant value. Constant value, and this is a January output. So using the fuzzy logic designer apps from Matlab R2020B. Second step, we have to do the fuzzifications, mean fuzzify our inputs. Our inputs is only the, I think, the time series monthly data. Monthly data. Then we have all the January from all the January input from all the years 2009 to 2020. Then we fuzzify it into here 10 fuzzy set. Then our January output is constant value. And then the fuzzy rule, we use if the January input is in A1, then the January output will be the first membership function. And then if the January input is in membership function A2, then the January output will be in the membership function 2 until the last one. Similarly, where we can click this one, and then output is where or you put it out the logical add the rules or change the rules, delete the rules, or you change your fuzzy rules there. And then to view the forecast, we can have this rule viewers. we got I think tenth months, is it tenth? Tenth data there. So if we input K1 data, so the output is here. This is the generate output here. So the methodology for the forecasting to so if you use a fuzzy rule viewer, you have to do one by one to forecast it one shot from 2009 to 2020. What we need to do is actually the FIS was exported to the workspace as a variable gen, as we save it as a gen FIS. Then the historical January data from 2009 to 2020 was forecasted using the command. This is a variable that I create. Gen forecasted equal to eval FIS. Okay. Uh, Gen is actually the January historical data where I save in the workspace historical data as a gen. Gen FIS is the FIS that we created just now. Then one shot we can get the forecasted result from January from January 2009 to 2020. To forecast for 2021, what we need to do is we need the input for 2021. The input for 2021 will be average it from 2019 to 2020. Okay, to obtain the input for January 2021, and then the input of January fees in figure 2 will be changed from 2009 to 2021, and then output of January fees in figure 3 will be changed from 2009 to 2021. Mean the we add in year 2021, so the input will add in 1 and 3, the output will be add out 1 and 3. Okay. So once the January consumption was obtained, the process is repeated for February, March till December. And the performance of the above time series of the uh, of the freeze forecasting method can be measured by mean absolute percentage error as you have the absolute yt is a real data minus a cap yt is a forecasted data. So this is absolute error divide by yt, so this will become relative error. When we sum out everything, we got the absolute relative errors. And then if we multiply by 100%, we have the absolute percentage error. If we divide by number of n data, will become mean absolute percentage error, MAPE. And this is the result. The monthly UTHM electricity consumptions by years from 2009 to 2020. Each line represents a years of the electricity consumptions. This is collection of the time series data from 2009 to 2020, which is in increasing and then decreasing trend. Here because this graph shows actually is only the result from January 2009 to December 2019. The recent data up to 2020, I haven't completed the February to December forecast. This is the old result that I obtained, where the blue shows the actual data, the red is a forecasted data, and this is the forecasted for 2019 data. And the MAPE for the fees is 2.32%. It's quite low if we compare to the I think the N in the previous video or in the other scale. I think technique using time series models or the Excel trend line or the multiple linear regression in our previous video there. And then we are going to the technical scale do how we do the how we define the fuzzy set. Okay. Okay, what I'm going to do is I can copy it. Okay, what we have, okay, this is all the January data, January, okay, electricity consumption data from year 2009 to 2020. Oh, here, 21. Okay, this one I include the 2021, and then, okay, going to sort it. Okay, and then we are going to sort it. Sort in the ascending order. So sort in the ascending order, and then we find the, okay, the distance. Get the distance here. Distance is a, okay, mean the distance in magnitude. So absolute value of the next data. Okay, deduct the previous data. So the ABS, okay, of the next sorted data minus the previous, okay, data. So distance is absolute value. Okay, later on, find this is a distance minus average distance squared. So AD, okay, AD is the average, average of the D lah. So the AD is average distance. So now we find the magnitude. So ABS, or if you don't put ABS, when you square also you get positive. ABS, the D minus the, okay, average distance is a constant, so make sure you constant it by putting dollar in front and at the back. Okay, right. Okay, and then you square it. So this is a, okay, D minus AD squared, because we are going to find the standard deviation sigma. Okay, sigma will be the square root of average of D minus AD squared. Mean, okay, when you have the average of this one, this give you the variance. When you take square root of the variance, you get the standard deviation sigma. So SQRT is a square root of the average of, okay, D minus AD squared. So the sigma, and then, okay, means that the the distance, okay, of distance is mean, okay, the difference between these two data. So between the lower bound will be the, okay, the minimum value of your data minus the sigma, all right. Sorry, before that, before you find the D, hold on. Okay, in the average distance, okay, D will be in the here, sorry, average distance minus the sigma, and then the average distance plus the sigma. So mean D should be in between. Take the average distance, deduct with sigma. So D should be inside this interval. Okay, upper bound for the distance will be the average distance plus the sigma. Okay, so mean D should be in this interval. Hence, this D is actually outside of the interval. Yeah, the rest is already inside the interval. Then the new average distance will be we average, okay, all the D which is in the interval. Okay, after that, okay, you're going to find the lower bound, okay, lower bound and the upper bound of the universe. Okay, lower bound of the universe will be the minimum data, okay, minus the new average distance. Upper bound will be the, okay, the highest, okay, data plus the average distance. So this is a, okay, lower bound of the universe, upper bound of the universe. Okay, and then since we're going to use FIS, we need the fuzzy set. Okay, let's say the first fuzzy set, let's, okay, I denote it as A1. I'm going to use a trapezoidal fuzzy set. So you have the 4 value A, B, C, D value. Okay, the first value of the A will be equal to the, okay, lower bound, and then the next value of the B is actually the A plus the, okay, new distance, a new average distance, sorry, new average distance, and then C will be B plus new average distance. Okay, so D will be the, D is a C plus new average distance. Okay, the next fuzzy set A2 is actually the value of next A equal to the previous C, the value for the next B equal to the previous, okay, D. So your trapezium will be value will be overlaps. Then these two you can copy it down. Okay, then I can copy down. These are all the value for my fuzzy set. Okay, how many set you want to form is depend on the upper bound. 2955. 2955. Is it correct? Okay, hold on. Okay, my upper bound plus the average distance. Oh. Okay, upper bound. Okay, correct. So I repeat, the lower bound is your minimum data. The smallest data add up with new average distance. Then the upper bound is the, okay, the maximum data add up with the new average distance. So the universe, okay, of the, okay, upper bound of the universe is 2955.25. So you, okay, build the fuzzy set, okay, 2493296282. So until hmm, okay, let me check the value. The, okay, we build it until where's the 2955. So A13, A13, A13. Because okay, theoretically the last value of D is equal to the upper bound. So but because the increment from A to B, B to C, C to D are constant with 19 new average distance, so that's impossible okay for us to get the last value of D exactly equal to upper bound. So in that case, you can have a higher value than the upper bound. So mean we need to build okay 13 fuzzy set based on these values. So it may goes now it may goes to okay here this one close it. The apps in the Matlab apps fuzzy logic designer. Okay, this is fuzzy logic designer. Okay, and then far new okay Sugeno where the output is a constant. Okay, okay I use a Sugeno, and then the input okay, okay double click the input, you get this membership function editor untitled 2 here. Defaults they give you 3 membership function. Okay, so I'm going to okay total we want 13 13 membership functions. So I go to edit, add membership function. Each time I want the trapezoidal membership function. So 12, add one more. Okay, trapezoidal. So total I have 14. Want the first one. Okay. So MF1 I change it to okay A1. A1. And then the display range, okay, you can key in the display range, okay, we key in the lower bound 396.5359. I may key in the range, may key in let's say 396. Okay, I key 396, upper bound 2955. I key in a bit greater because my value here 3092, so I key in 3093. In the last set 3092.29, so I key in 3093. This 396 point something, so I key in 396. Okay, key in the lower bound 396, upper bound based on the last value of the D 3093. Okay, and then click I think which one A1 okay, I want it to change to trapezium. And then the parameters, okay, parameters for A1, I select this thing, A, B, C, D. I get, okay, the first, okay, fuzzy set A1. So this is a trapezoidal, okay, fuzzy set, okay. Then the A2, okay, make sure I click the A2, where's the A2? Is it this one? 3. A, MF2, change it, label it as A2. I use trapezoidal. Okay, this is the automatic okay adjust, okay, but I want to use the value that okay here. So this is my A1, A2. Where's A4? A3. Okay. MF3, change it to A3. Okay, A3 and select okay the ABCD value there. Ui, yeah, put it here. Okay. A3. Oh, make sure this is trapezoidal. So A3. So the ABC value, this is actually this point A, B, C, D bottom. Okay, find the 4. So A4. Okay, A4, go to select, okay, ABCD value here, trapezoidal. So this is a A4, A5, okay, later on A6, it's a 7, okay, A7, and then AX, this 13, it's 8, 7, AX, okay, A8, and then A9, okay, and then A10, then A11, so A12, okay, lastly the A13, okay, so I have built so okay 11 membership functions, A1, A13. Okay, based on this technique that okay I got it is actually from the idea of fuzzy time series. Okay, after that, okay, I'm going to create the output. The output is actually the constant value. We should have 13 output also. So add, okay, 9, okay, so 12 already. Add one more. Okay, and then the midpoint. Okay, okay, the output will take the midpoint of the trapezoidal sets there. So the average of, okay, the ABCD value. Okay. Okay, then you copy the first value will be the membership function 1. The parameters is this value. One, okay. For the output of membership function ones, okay, we can, let's say, key in this value, put it into the parameters here. Okay. And then membership function 2, you can copy the midpoint of the second fuzzy set, put it here. Okay, membership function 3, Control C. And then repeat for membership function 4. Okay, and then membership function 5. Okay, membership function 6. Then 7, the next value. Then number 8, the next value of the midpoint. And then number 9, okay, the next value of the midpoint. Okay, 10. Okay, next value of the midpoint. 10. Okay, 11. Okay, 11 here. 12. Okay, we need 13. 13. So I add 1. Yeah. 13. 13, the last value here. 2943, check. 12, 2743, 11, 2543, 10, 2343, 9, 2144, 8, 1944, around it, 7, 1744, number 6, 1545, number 5, membership function 5, 1345, number 4, 1145, number 3, 946, number 2, 746, number 1, 546.3. Okay, and then you can view the rules. Oh God, you got no rules here. So we got no rules yet, so we edit the rules. Okay, we put up the rules. If the input is in A1, then the output is in membership function 1. Then you add rule. If the input is in A2, then the output is in the membership function 2. You add rules. If the input is in A3, then the output is in the midpoint of the membership. Is output is MF3 is actually midpoint of A3. So add rule. So repeat. Okay, for all the membership functions. 6, 7, 7. Add the rule. 8 and MF8. 9, 9, 10, 10, 11, 11, 12, 12. Okay, so I got 13 rules there. Because I have only the time series data, and I've the generate time series data are falsified into 13 membership function, and then the rule is if the inputs belong to A1, then the output is takes the midpoint of A1, and so on. Then you close it so you can view here. So for example, now you want to forecast a January. I put 496.379. I give you the output 546. 546. So this is a real data predicted as 546. So you may do it one by one for all the years, or one shot. You can actually, I think, save. Then you can close it. You can actually file, export. Export what? To workspace. The name, let's say this is a January FIS. January FIS. So Jan FIS. Export this thing. Next round, you want to open. If you close the Matlab, you want to open, you use import, and then import from far. Look at the Jan FIS. Okay. And then you see okay. This is the Jan FIS here. Okay, because previously I have opened my Matlab, I got other scale or workspace, workspace there. So this is a Jan FIS. Okay, and to forecast it, I need this is what I have done here. Okay, generate. This is all the January data, and then I just use Jan forecasted equal to eval FIS. Okay, Jan is actually this January historical data. Jan FIS is actually the FIS that I export. This FIS structure that I export. Okay, and then I can run it. My editor. No. So this is the forecasted output. You can copy it. Okay, let's see. I will put it here. Put it here. Oh, no. The value is no, don't put it from here. We copy it from the workspace, the variable there. Gen forecasted here. Control A. I put it here. Control V. So the same thing. I want Control C. So this is okay, the forecasted from the FIS, and you can do all the error analysis ABS of the real data minus the forecasted data, and you can find the squared error is your absolute errors power 2 power 2. You can do the relative error, which is your absolute errors divided by your real data. So this is the absolute error divided by real data here. So these are relative errors. Then you can copy it down. You can find the when you average your absolute error, you get the mean absolute errors. So you average all your absolute errors, you get mean absolute errors. This is a MSE. When you average all the squared error, you get the MSE. You can have MAPE. This one you average all the relative errors. To make it percentage, you time 100%. Because average, so you have got MAPE by multiplying 100%. So this is only the January data. This is only the January data. So you repeat for February, March until December. March until December. You might say, why so troublesome? Why not you forecast? Why you falsify the whole data? Why can't we do it for the whole data? I will show you what happens. Here, actually, we have the data. We have the data from January 2009, until December 2020. This 2021 is actually I average from 2019 and 2020. And then so I sort all the data from 2009 to 2020. Then I find the distance. Later on, the average distance. The average distance is average of the distance. And then we find the sigma. Sigma is the square root of square root of the average of the d minus average distance squared. As just now. And then the d will be when you take the AD, AD minus sigma. This is a lower bound for your distance. Upper bound of the distance is AD plus sigma. And then we notice sum of the d which is outside our interval. So eliminate those d which is outside our interval. Then I get I average it again. I get the new average, new AD. Then I will find my lower bound using the smallest data add up with minus the new AD. Upper bound is the last data is the last biggest data add up with the new AD. And then I fuzzify. I think I fuzzify. Because our bound lower bound 482.73 will be equal to the first A of the first fuzzy set. And the upper bound upper bound, hopefully I find correct. Because the new AD is small, quite small. So upper bound 3271, and the average distance is small, mean the value between A, B, C, D are quite small. So I got 3271. Oh, here still not enough. I should have, okay, 103 membership function. 103 membership function. Okay, if you go to build it like just now the Jan forecast here. Okay, this one until 13 already so messy. If you do it scale for 100, how many here? 131, 103, 103 is quite messy. It's quite messy. So if you are okay, you can. I think it's quite messy to do it that way. So that's why I still break it in. I will collect all the January data, okay, and then forecast the forecast mid 2009 to 2020 and forecast January 2021. Then repeat it for February, March, okay. So you have to repeat total is 12 times. This one is okay, but it's troublesome because too many membership function, to do it there. So that's why still have to break it slowly. And then later on, how to get all these things. Okay, once you get all the month done, you can put it back. I think here. This is only January, right? So you put it back January to the January position. I mean, like this. Put it back properly. Okay, January data, put it to the location, and once you're done for February, put it to location, and then you find back the errors. Then you can plot the real data and the forecasted data. You can calculate all kind of errors. Okay, so this is because we have only the time series data. If we got multivariate data, maybe you want to forecast electricity consumption instead of the historical data. You got temperature data. Maybe you got temperature data. Then you may set something like that. If the temperature is high or you have the humidity, you can set all kind of rules there. Or let's say temperature is high, then the electricity uh, may be high because you need to turn on aircon, fan, everything. If temperature is too cold, so maybe you want to turn on heater, so you need more, okay, electricity consumption. So you can set all kind of rules. Because I have only the, okay, mine is only the time series data, and this rule that I got the idea is actually from the idea of fuzzy time series, okay, where you put it similar concept there. If the input is in the membership function 1, then the output, it will take the midpoint of membership function 1. But this is that one, they have the, is actually yearly data. If I got monthly data, what I can think, if I do it scale like this, just now it sees too many membership function to be uh, declared, too many. Okay, and then what gen fees. Okay, this one when we export, actually, okay, I also try this one. We export and then I try to add in here, but I couldn't open backs. Actually, I have tried, but couldn't open back this thing to runs. In here, because the gen fees is actually from here. As a gen fees, if I open, let's say, okay. So okay, for this one is actually last time what I did is from the data 2009 to I think 2018. The 19 is actually I average 2017 and 18. That's why I got the actual and the forecasted, but it's actually the 2019 I average, okay, the 2018 and 2000 17 data. Okay, and then now okay, so we add in 1 year, so you have to redo again the process. Okay, but actually now it's December 2022. If I got, okay, 2 more years data, the process have to be, okay, redo again, and is, okay, because each time I add in the data, I have to fuzzify against my, okay, membership functions, because we add in data. Okay, the my new average, okay, distance may be different, so I have to fuzzify again everything, and then have to redo again this thing. So for the February, okay, to the December, I leave it for each of you will do 1 month, okay, for, okay, for your assignments. Okay, so with this, okay, thank you for your attentions.